Good afternoon, ladies and gentlemen. Welcome to the graveyard shift. The last session looked at ports from a bird's eye view in terms of green potential, constraints on becoming green, decarbonisation. And this last session of the day takes a closer look at green equipment, or zero emissions at the point of use equipment, we can say that. The first speaker is Marco Lenzen from Konecranes Gottwald, who will talk about not just mobile cranes electrically powered when they're on the quay, but also battery takeaway for moving between different parts of the port. Then, sorry, that I've got that wrong. It's Jelle van der Waal from country manager. That's deliberate, you see. It's Jelle van der Waal, country manager of Kalmar Benelux. Obviously, they've got an electric reach stacker here, so Jelle's going to be addressing the broad question of sustainability through electrical operations, with reference to the new reach stacker, of course. And then the last speaker is Sebastian Simon from Liebherr Rostock, who will be talking about Liebherr's LHM, new LHM range of mobile cranes, harbour mobile cranes, in particular Patronic 2.0, the sort of second generation of the proven hybrid drive that Liebherr introduced some years ago on its mobile cranes, and also the battery takeaway that is now available for moving between different parts of the port without using diesel power. So, and then there'll be a Q&A. The idea is that the speakers don't speak for more than 10 minutes each, 10, 12 minutes each. So we have a lively Q&A. Perhaps we then move beyond electric towards, because a lot of people think electric is just an intermediate solution. We need to be looking beyond that at hydrogen and maybe ammonia, the e-fuels generally. And then we have to look at the constraints, the upstream difficulties. I mean, with electrical equipment in terms of sourcing the minerals, who controls the supply chains and so on. The difficulties of getting sufficient quantities of green hydrogen and green ammonia into port systems and so on. So, Jelle, over to you, please.
Hello, good afternoon. My name is Jelle van der Waal, Country Director of Kalmar Mobile Solutions in the Benelux. And I'm very honored here today to talk to you about sustainability. Within Kalmar, electrification is a key element of our journey into sustainability. Which is actually not a coincidence. No, it was a decision to invest into sustainability and to building a roadmap to make our heavy vehicles electric. We have not taken that decision just on ourselves. We have listened to our customers. We have worked together with our technology partners, and eventually we really knew that this was what our market was looking for. Our presentation contains about 3 elements. I will talk you through our journey towards eco-efficiency and the way that we can support you with this. I will present our full electric portfolio, and I will highlight our electric reach stacker. We as Cargotec, and with that Kalmar, feel it as our responsibility to contribute in lowering the global CO2 emissions. We have committed ourselves to be a 1.5 degree company, which means that, amongst other things, we will reduce our emissions from our cargo handling equipment by at least 50% up to 2030. Compared to the emissions of 2019. The first element of our presentation is about Kalmar's 5 steps toward eco-efficiency. We would like to help you to investigate how you can improve the eco-efficiency of your current operations, and how we can start today to deliver an eco-efficient future, step by step. The first step is the eco-efficient vision and targets. First, you have to determine a goal or a target which could be described in terms of reduction of CO2 emissions and a timeline for getting there. Once this is determined, it is necessary to also identify the baseline by evaluating emission levels in the current operations. The baseline and that future vision will then be used as a foundation for a roadmap that will define actions needed to reach your sustainability goals and to get from the current state to the future target. One of the major challenges for creating an eco-efficient cargo handling operation is assessing a sustainable energy supply. Step 2 is about infrastructure and charging strategy. Things to be considered here are what will be the cost involved for infrastructure, both for the new installation, but also for the cost of electricity, for example. It is also important to investigate the short and long-term plans for electricity generation by solar panels, for example, and the grid capacity. And what will the introduction of a zero-emission solution like high-voltage equipment mean for your daily operations in terms of safety, maintenance, but also the management of charging the battery. That is also something new, and you have to consider. Step number 3, a central step for us, because that is about to look at the eco-efficient solutions, like zero-emission machines, battery electric, or hydrogen fuel cell-powered machines, or equipment with eco-efficient powertrains using less fuel than traditional diesel machines, like the Kalmar Eco Reach Stacker with the fuel saving guarantee, for example, and also as a here and now solution to look at an alternative fuel, like HVO 100, which is a paraffinic diesel, which have the possibility to reduce CO2 emissions up to 90%. Targets are set, infrastructure has been investigated, and the available eco-efficient solutions are listed. It's now time to look at the operational scenarios and the business case in step number 4. Kalmar can help you to get an overview of the fleet transition over time, needed to reach your sustainability targets, by analyzing your operational data, for example, by analyzing our Kalmar Insight. The return of investment should be based on a total cost of ownership calculation. Electric equipment might be more expensive up front, but with less moving parts, most likely the maintenance costs are lower, which means that the break-even point can come surprisingly fast. The final stage, step number 5, is about making the most out of your eco-efficient investment, making sure to keep track towards your sustainability targets. So we are talking about implementation and optimization in step number 5. Switching to electrically powered equipment will have fundamental impact for your workflows, your infrastructure, service and maintenance, and also to develop people and skills. New ways to operate and service equipment requires instructions and practice, and maybe old habits of people needs to be adjusted. Also, safety training should be highlighted when you're going to work with high voltage machines. Summarized, these are the 5 steps of eco-efficiency from Kalmar, and we are there every step of the way to assist you with those 5 steps. At the end of 2021, and unfortunately that was still online, we had the launch of our new era of logistics. It was the launch of a complete range of heavy electric vehicles. We have launched here our electric reach stacker, of which I will tell you a bit more in the upcoming slides. And we already launched earlier electric forklift trucks, but now we have launched them in its full range of capacity levels. And also the next generation of terminal tractor has been launched at that moment of time, also powered by an electric battery. This makes that all your container handling operations can be done in an electric way with our Kalmar products. Now there is a short movie about our electric reach stacker.
Reach stacker. The time is now to go electric. The time to consider an electrically powered reach stacker from Kalmar. Going electric means you will produce zero carbon emissions at source, helping your business drive down your carbon footprint and preparing your business for a low carbon future. Our electrically powered reach stacker also delivers on productivity and safety. With a choice of battery and charging solutions, we can tailor a battery solution that's right for your work cycles, maintaining your current levels of productivity, if not helping to improve them. All of our electrically powered reach stackers come fitted with a thermal management system, which allows you to operate normally even in extreme weather conditions. And Kalmar Insight allows you to track your equipment so you can monitor and optimize its performance in real time. Being electrically powered helps provide a cleaner, safer work environment for your drivers, which is great for everyone. Plus, with Kalmar Services' range of support services, we can make sure your reach stacker keeps moving. The Kalmar Electric Reach Stacker.
The time is now to go electric. So what are you waiting for?
It's a very impressive machine. The machine is also displayed actually at our stand. So please visit our stand as well to have a good look to the machine. It's an impressive machine, to say. We are very proud that we can offer it with a wide cargo handling application portfolio, an energy efficient design, capacities and performances like a normal diesel reach stacker. We have 4 different lithium-ion batteries. It is operational in every climate, and we offer a wide offering of charging solutions based on global standards. And if you are using a renewable energy source, it can save up to 100 tons of CO2 per year compared to a normal traditional reach stacker. A key part of the design of the electric reach stacker is by nature the energy efficiency of the powertrain. Even though it's a zero-emission solution, one of the criteria is still that the use of energy needs to be minimized without compromising on performance. Minimizing overall energy consumption and maximizing energy recovery will keep the kilowatts per hour as low as possible. This will ensure that the charging intervals become longer. As the lifetime of a lithium-ion battery is based on the kilowatts hours used, lower energy consumption will also extend the battery lifetime, and it will also have a positive effect on the residual value of the reach stacker. As the battery is the single most expensive part of the machine, optimizing energy consumption offers the possibility to choose between a wider range of batteries. A smaller battery can be a cheaper and a smarter option for your operation. One battery size does not fit it all, and that is why we are offering 4 different lithium-ion batteries in order to accommodate all productivity requirements. They all have a very long lifetime and to ensure the residual value of the machine. And it will come with a 5-year warranty. And as they are lithium-ion batteries, opportunity charging is key to maximize operational efficiency. And that last part is extremely important. We cannot say that enough. If you look to the operating hours, Of course, depending on the battery size and the operational requirements, same as a diesel machine. But the non-stop drive time can be anything from 3 to almost 10 hours. With lithium-ion batteries, you have the advantage of opportunity charging. So whenever drivers are taking a break or there is a productivity standstill, make sure that they use that time for charging. That way you will be able to select a smaller battery than what is needed for non-stop operation. And it will also enable you to run more than one shift. Our machine is equipped with a thermal management system that makes that the machine can be operational from anything from harsh winter, minus 30 degrees, to plus 40, blazing sunshine, without impacting the operational performance of the electric reach stacker. As I have already mentioned, opportunity charging is key to electrification when using lithium-ion batteries. Using scheduled breaks, standstill time, shift breaks to top off the battery. Here are some estimated charging times to fully charge the battery in case the battery is fully depleted. In this example, we have listed 2 charging capacities. And you can see that the smallest battery can be fully charged during a lunch break. There will be many new things and operational data to keep track of when using an electric machine. This will be available in Kalmar Insight, where you will have access to battery health, state of charge and temperature, energy uses and energy consumption, and charging usage and behavior for charging management planning. How much will it actually impact the CO2 emissions to go electric? This is basically the most important reason why we have designed our electric reach stacker. Did you know that 1 liter of diesel actually becomes 2.64 kilos of CO2 in the combustion process? And that is quite a lot when you know that a traditional diesel reach stacker is consuming around 18 liters of diesel per hour. A bit of a disclaimer at the end of the presentation. In this graph, we would like to show you that the zero-emission machine not always means that you are 100% clean in your operations. Most countries in Europe are not delivering 100% renewable energy yet. And in this graph, you can see that from an emission point of view, it will actually be more green to choose an eco-reach stacker than an electric reach stacker. The only 2 countries with, let's say, being close to 100% renewable energy are Norway and Sweden. So in summary, we as Kalmar are extremely proud that we can contribute to the important journey which we see all over our society to make supply chains more sustainable. With the electrification of our mobile equipment fleet, we bring a full range of offerings to the market. And we are looking forward to do that together. I would like to thank you for your attention, and I hope we can see you at our stand.
Hello everybody, also warm welcome from my side. As you might have noticed, I'm not Jörg Müller, my name is Marco Lenzen. I'm also from the engineering department of Konecranes Gottwald. Jörg Müller wasn't able to come this evening, and I'm here to represent him as best as I can. To get ourselves into the right mood for this presentation, I will start off with a brief video about our first battery-driven mobile harbor crane that we have recently delivered to one of our customers in Sweden.
Welcome to Skellefteå. This is where we develop the future.
Skellefteå is becoming the new European capital of battery production. The city has accepted a general eco-efficiency challenge, including its Baltic seaport.
The new battery plant that Northvolt is building in the Skellefteå area is putting another focus on the sustainability. That is why we absolutely wanted a full electric crane, and which we found at Konecranes.
The world's first battery-driven mobile harbor crane is now operating in Skellefteå. It is powered at the quay by electricity from the port grid. battery power is used instead of a diesel engine to move the crane within the port.
We are proud to operate the world's first electric crane with a battery backup system to contribute to a sustainable port operation in Skellefteå.
As you could see in the video, our customer is aiming for an eco-efficient and sustainable port concept. And for that reason, the customer was asking us to provide a zero-emission crane. Actually, building zero-emission crane is nothing new for Konecranes because we have our external power supply and we are actually delivering zero-emission cranes for years now. But the customer had a special demand. He wanted also to be able to travel with the crane without any emission while the crane is unplugged from the harbor mains. Besides that requirement, the customer wanted also to find some solution to reduce the noise emission. And that was the point where we came up with our battery solution. Fortunately, Konecranes has already a lot of experience with full electric cranes, and we have also a certain experience with battery technology, but we will see a little bit more about that on the next slides. What we see on this slide is the solution for the power supply that we have provided for this project. Here on the left side, you could see on the left side, you can see our external power supply. We have already delivered this multiple times all over the world. This power supply is designed for high-performance cargo handling, and we can also adjust the solution to the customer demands in terms of different voltages at the harbor, etc. The new thing for this solution, you can see on the right side, this is our onboard battery pack. With this battery pack, this battery pack is designed for the traveling motion, but it gives us also certain ability for emergency operation. Here on this slide, you can see some facts and figures about the ability of the crane while it's operated with the batteries. For this project, we have endurance for the batteries about 70 minutes, and we reach a maximum traveling speed about 30 minutes per meter. Meter per minute. That means that we have a distance that we can reach about 0.1 kilometers. Obviously, the reachable distance depends on the crane size, especially on the crane weight. And we are talking from the smallest to the largest crane about distances that we can reach between 1.7 kilometers for the heaviest crane and roughly 2.7 kilometers for the smallest crane. When I talk about traveling, I do not only mean traveling. The battery supply is also able to prop and unprop the crane. The idea is that you have the crane in the initial position. You can unplug it from the harbor mains. You can unprop the crane, lift up the stabilizer pads, move the crane to the target destination and prop it again. And after the crane is propped, you can connect it again to your harbor mains. Behind these numbers, there's a certain, let's say, standardized traveling cycle that also includes a 50% time share of steering while the crane is traveling and a 10% time share of accelerating while the crane is traveling. As I've mentioned before, actually the battery drive is designed for the traveling, but it gives us the opportunity to have a certain emergency operation, which you can see on the bottom part of this slide. Depending on the load that is handled, we are able to conduct between 10 and 20 load cycles. We have reduced speeds when the crane is operating with batteries, and we can only do single movements. That means no slewing and luffing in parallel, but one after another. But to have this opportunity, just in case there is any issue with your power mains, is, from my point of view, a clear advantage of this solution. I've mentioned that we have already a certain experience with battery technology. This experience is coming from our AGVs, which you can see here on the right side of the slide. These AGVs are designed for 24/7 high-performance operation, and the batteries reach a lifetime about 2,800 charging cycles. And for our mobile harbor crane, we have adopted this solution, and we are using more or less exactly the same technology also for our mobile harbor cranes now, which you can see here on the bottom part of the slide. For the project in Sweden, we have used a capacity about 230 kilowatt hours, or respectively 324 ampere hours. You can see that we have assembled the battery pack below the superstructure. It's actually not below the counterweight, it's more or less below the hoist unit. There is a cabinet where the single battery units are placed in to protect them from the environment conditions, and also to enable us to provide an air conditioning so that we can use the batteries regardless of the climate conditions. And for sure, we have also the possibility, in case of there is any issue with a single battery unit, to exchange the single units. What you can see here on this slide is a rough schematic about our system architecture in our mobile harbor cranes. I've said that we have a lot of experience in building fully electric cranes. When you take a look at our main consumers here on the bottom part, obviously the slewing gear and the hoist is purely electrically driven, but one could say that our luffing gear and also the traveling gear is still hydraulically driven. But we need to remember that also for our hydraulic unit, for the main pump, we have an electric motor for the power supply. So from system architecture point of view, one could also say that we have a full electric crane, but with a liquid gearbox for the luffing gear and the traveling motion. So, and for that reason, it was not that difficult to introduce the batteries, because our architecture is already ready for battery solutions. Another advantage that we have with this architecture is that we can recover energy. For example, when we are lowering a load with the hoist, we are not using a frictional brake to control the speed, but the electrical motor as a generator, and the generator or the generated energy can be directly used for another movement in parallel in case of there is a power demand, for example, on the luffing drive or the slewing drive. If there is no power demand while we are recovering the energy for the hoist in this example, we can also recover the energy with our batteries. And are the batteries already charged, we can feed back the excessive energy into the harbor mains. So that's the way how we handle the energy inside of our mobile harbor cranes. There are also different opportunities for charging the batteries. As I mentioned before, you can use the recovered energy for charging the batteries. You can also use the auxiliary power for charging the batteries, and you can use the harbor mains for charging the batteries. And we see a little bit more about these opportunities on this slide. Since it's recommended anyway to connect the crane to the auxiliary power while the crane is out of operation, one could say that with the auxiliary power, the crane or the batteries are charged more or less automatically. You do not need to care about it. We can charge with the auxiliary power with a maximum power of 15 kilowatts, which leads to a charging time for a full charging cycle about 16 hours. And we can use a standard power supply, 400 volts and 63 amperes. The batteries are also automatically charged when the crane is connected to the harbor mains. When the crane is in operation, we reach maximum charging power about 160 kilowatts. That means the batteries are fully charged within 2 hours. when the crane is out of operation and the main contactor is switched off, we have still 35 kilowatts, which leads to a charging time of 7.5 hours. Yes, I'm also happy to see that we discovered during the commissioning of our first project some additional advantages of this solution. For example, we were able to do the entire commissioning without any connection to the harbor mains, and this gave us a certain flexibility during the commissioning. Also, we saw that the very challenging environment condition with temperatures up to minus 30 degrees were not hindering us to do the commissioning. And I'm pretty sure that we will have multiple of such projects in the future. And I'm happy to see that we already have the next orders for such cranes in our books. We will shortly deliver 2 more units to our customer in Port of San Diego, USA. In this case, we are talking about ESP9 cranes with a maximum lifting capacity about 200 tons each. But the main concept that I've explained before is more or less the same. For further information, feel free to visit our webpage, konecranes.com/generation6. There we'll find more material behind our new technology solutions. Thank you for your attention, and I'm looking forward for the discussion afterwards.
Dear audience, it's a pleasure for me to be here in front of you today, talking about the futures, the topics of the future. But before I start with my presentation, I would like to review the past a bit with you. We go back to 1997, a great year for innovations. The first mobile phone with colored screen was released to the market. It was not a smartphone, but a big improvement to all what was there until then. Another innovation had a rising trend. The internet had incredibly 6 million users. And Liebherr launched its first electric-driven crane to the market. 1997, a quarter of a century ago. So since then, we are able to provide emission-free equipment to our customers. And of course, the mobile harbor crane is made to work on different key sites. The crane has to bridge a certain distance to do that. And of course, what will be also possible for Liebherr mobile harbor cranes to bridge this distance with 0 emissions or without emissions due to a battery pack installed. Our battery pack will have an aimed lifetime of 10 years, a 260 kilowatts capacity, and of course, we also provide an emergency operation in case the onshore power supply is down for whatever reason. Furthermore, the traveling distance will be up to 2 kilometers for our cranes. Now, I could close my presentation because we provide 0 emission equipment to the market. But when we have a look to the sales statistics, there is another story we have to consider. When we look at the cranes which are sold with an electric drive on board, we see there's a good trend. The customers are adopting this opportunity. In 2021, we had a record year of cranes with an electric drive on board of 30%. But on the other hand, vice versa, it can be said that still 70% of the cranes which are going out into the market still have a combustion engine on board. So we as Liebherr, we have to do something also for those customers. We have a responsibility that those customers can also at least reduce their carbon emissions. So this is why my presentation today is called Onshore Power Supply and Alternatives. It's obvious that the second pile in the decarbonization is to increase the efficiency of the existing drives. We do this with our new crane series. Because in our new crane series, there's the so-called Pactronic 2 on board. The Pactronic 2 is the energy recuperation system, and it's extremely powerful. 700 kilowatts power output is possible with the Pactronic. So it replaces the second diesel engine, which is necessary to have extremely high hoisting speeds. So this is what we can do with the boosting mode. We increase the hoisting speeds and the operational speeds. But in some cases, the crane is too fast for the hinterland infrastructure. So we also provide the so-called green mode in order to relieve the prime mover and save energy or diesel. There are a lot of more possibilities to increase the drive efficiency of our crane, but due to the time, I have only the possibility to present you the Pactronic 2.0 today. But in case you're interested in, please visit me at the booth so we can have further conversations about that. When we talk about alternatives, we have to consider, of course, alternative fuels. I think it's also obvious. One synthetic fuel, which is already available, is the HVO 100. So our cranes are able to use this drive, this fuel, and taken into the consideration that this synthetic diesel is made of raw materials which collect the carbons before the combustion process out of the atmosphere. We can consider that the crane has 90% less CO2 emission during the operation. And our customers are very happy that we have this opportunity. Now I will change my perspective a bit, away from the mobile harbor cranes going up to the Liebherr overall perspective. As you know, we have a lot of more products. And when we talk about alternative fuels, we also have to consider e-fuels. Means fuels, synthetic fuels, made of renewable energy sources like wind, sun, or water energy. Frankly speaking, I cannot say which of them, or if any of them, will play a big role in the port infrastructure in the future. But what I can say is that Liebherr is preparing for it. Liebherr is part of different research and development programs in order to solve the problems of the future, to use those e-fuels, to provide the right product at the right time. To sum up my little presentation, at the moment, the best way to decarbonize mobile harbor cranes is via onshore power supply, which we gave into the market already 25 years ago. And for the future, we do not exclude any technology from the outset. We look in any direction. And now, I'm really looking forward for the Q&A session to answer also your question, get into the discussion. Thank you very much.
Well, thank you very much to the panel for keeping it more or less in line with the request of the organisers to allow maximum time for Q&A. Just to kick things off, how do you curate, how do you tell your customer about the lifespan of a battery, a Lion-ion battery, whether it's used in a lift truck, heavy lift truck, or a mobile crane? There must be. This is the ideal first life of a battery. Then we have a second life, and then finally maybe a third life as an energy storage system, and finally a fourth life when you have to recycle. And how much of the battery can be recycled? That's a question for everyone, actually, really, if anyone wants to answer it.
Yeah, maybe I can start. So what we can say is the number of charging cycles what our batteries can take. And this is, as I mentioned before, an experience that we have from our AGVs that we are producing for several years now.
And we know from the Kalmar presentation that the batteries are modular, the packs are modular. In terms of the mobile cranes, presumably it's on a case-by-case basis. You have to take into account the configuration of the port and so on. But you're talking about 2.5 kilometers maximum of long travel.
Yes, sorry. That was not a case-by-case study. That was a, let's say, crane model by crane model statement.
Right.
So depending on the crane weights, you have a different distance that you can reach with our battery solution.
And not every port has got the advantage of a port like Skellefteå with plenty of green electricity, and also the advantage of having it, which I didn't know, a battery, a gigafactory being built there. So when would you recommend to a customer, actually, you might be better off with a diesel genset, Sebastian, would you like to take that one? Not on a diesel genset, but fuel, diesel or HVO.
Yeah, what we learned during our analysis that not every customer has the possibility to plug in its crane and an onshore power supply. And of course, it's obvious for those customers, HVO makes 100% sense in order to go into a more decarbonized direction. What we saw in the presentation is also that we see a rising trend. So for mobile harbor cranes, every third crane can be connected to an onshore power supply. And I expect that this will be boosted up in the future, of course, because the topic is getting more and more important. But there has to be something done. Of course, the infrastructure has to be developed. And there are some factors accelerating this, like lower electrical cost compared to diesel. Yeah? So for some customers, it is cheaper to run the crane with a diesel engine instead of plug it into an onshore power supply. And this is something where I can understand why should a customer run then the crane with an e-drive, because then his business will run away. So there has to be some more regulations, or also the possibility to buy green and also cheap electric energy.
Is there a tipping point on the price, do you think?
Yeah, for Europe, our analysis shows that if this the price difference between electric and diesel is over 60%, means that the kilowatt from the socket is 60% cheaper compared to the kilowatt you get out of a liter diesel, then the electrification density increases extremely. Yeah? So we have a few countries in Europe where it's very obvious. Yep.
Okay, thank you very much. Can we open it to the floor now, please? I'd invite questions. And please give your name, and there's a microphone coming. Name and organisation, please, and address whoever you want to answer the question. Thank you very much.
Okay, great. My name is Anthony Ackerman. I'm from Siemens in Australia. It's a generic question for all three of you. Great presentations, by the way. I'm really interested in the adaptation of battery technology in port terminal operations, and I was interested, we had a comment about the price impact that the battery system can potentially have on the asset. Obviously, there's been a huge fluctuation in the lithium prices over the last 18 months. Do you see the impact on that in regards to the competitiveness of these solutions for your customers?
I think that is currently still difficult to say. We are at, let's say, at our point, we are at the start of this technology. We still have to see if that is really impacting the let's say overall. Of course, the battery is the single most expensive component of the machine. So definitely, when the price is going up, then also the price of the machine is going up. But I think it will also be difficult to answer that question today, because we have no benchmark from there. But on the other hand, we should not forget that the fossil fuels will also increase in price significantly during the coming years. So difficult to answer that question.
Thank you.
Next question from the floor, please.
Hello, my name is Daniel Andrej. I'm also from the Siemens AG in Erlangen and responsible for crane applications. My question is, mobile harbor cranes are very specific in terms of peak power demands if connected to the shore supply. Is there a general strategy that you see, the question is to all three of you, to bring the peak power demands of the crane down to a, let's say, reasonable level?
You mean by peak shaving, for instance?
For instance, yes.
Yeah, so peak shaving will be one of the topics of the future, of course. Because when the crane does not consume that much power in peak, it would be much easier for the customer to apply with the respective infrastructures. So, of course, it makes sense to implement such technologies into the crane.
Maybe I can also give a comment on that. We already have high ultra capacitors in our portfolio. So for a standard crane, non-full electric crane or non-zero emission crane, let's say, we are meanwhile using smaller diesel engines, and we have some additional ultracapacitors to supply the peak power. And this is our approach to handle this.
From an engineering point of view, actually, I have to ask my colleague Mette maybe to answer that question about these peaks.
I mean, the the peak shaving, of course, it's going to be an issue if everybody wants to do the opportunity charging at 9, coffee break, and at lunch. We cannot do that. So charging management becomes an important question. You need the data for that. So we're monitoring everything with a fleet management system. So you can see operationally, so when do we need to charge? And you need that logic and intelligence to indicate you need to charge when you're at 50% state of charge of the battery and not wait until 20, because then you can do so that everyone is not charging at the same time. And then I think with time, the battery packs, once the first life is over, maybe it's the second life of the battery that can be used for power packs. You can charge them at night when electricity is available and cheap, and have that as backup during the day if you need to charge when grid capacity is limited or very expensive.
We haven't talked about the step beyond lithium-ion batteries, which is, I mean, Sebastian touched on it, e-fuels. We're looking at possibly green ammonia, green hydrogen, but let's just take the composition of an electrical machine. I was reading the other day that the average electric car is 200 kilograms of minerals, so copper, molybdenum, cobalt, etc. Whereas the standard petrol car is 30 kgs. So, where are these minerals going to come from? Who controls the supply chain? What about the governance of the countries where these come from? We have they come from the south mainly. What about the governance of these things? Do OEMs, big important OEMs like the three companies you gentlemen represent, do you take this into account in your thinking about what you're offering your customers?
Yes, of course. What we see is that green e-fuels will be some kind of a raw resource, because green e-fuels cannot be produced everywhere in a sensible way. So it does not make sense to produce green e-fuel and then ship it around the world to the operational point. It must be produced next to its operation. So therefore, this is what I meant. We consider for the future a mix of different e-fuels, whatever it makes sense at the position of the operation of the crane, of the actual position.
And I also think that there is actually no time to wait. Of course, we have to consider let's say, the development, as you were speaking about those things. But on the other hand, maybe electric is a here and now solution, and let's say for the coming years. But there is also no time to wait. So I think that it was already many years ago that we forced ourselves into a direction of coming to a more sustainable solution that was, let's say, in reach. And I think that when you look to the hydrogen solutions, it is a bit more difficult to let's say, make it in operation in our products. And it's also quite difficult for many ports to get a good, let's say, to get the product where you need it.
Well, clearly, if we go to e-fuels like ammonia, green ammonia or green hydrogen, then the infrastructure problems are just, someone's got to tackle those big time. But, I mean, there's just no free lunch on these things. I mean, just for example, it takes up to 27 kilograms of water to produce 1 kilogram of green hydrogen, depending on the amount of demineralization required. If it's clean water, it's only 9 kilograms of water. That's 9 liters of water for 1 kilogram of of green hydrogen, which will give you the same power density as 3 kilograms of diesel. So that would be a 3-to-1 ratio. Can I have some more questions from the floor, please, on anything to do with green, you know, whether it's e-fuels or battery electric? Any more questions from the floor? So these gentlemen would have liked more time to make their cases, so there must be something. There's 10 minutes to go. We can wrap up early if you like. Alternatively, if there's no further questions, I'd like to give everyone a further chance to make some comments, please. In turn, from that end, Sebastian, if you start and finish with you, Kjell. Okay, thank you.
Thanks a lot. I just can repeat, we are really try to look into the future to anticipate what the market needs, or what are the market needs in order to be decarbonized for the future, what is realistic, what will be the problems of the future. That's why LIPE is participating in that many research and development programs in order to solve the problems of the future. And I hope we will do it together with you. And in case you want to discuss this with me, I invite you, of course, to the booth, also maybe for a beer. Thank you very much.
I think we heard it already from the comments of my co-speakers, but I would say our current approach with the battery technology is not the end of the eco-efficient development. It's just the beginning. So I think there is a long way to go, and we are just at the start of it.
Yeah, and the last thing that I wanted to add to the presentation that we gave about the electric reach stacker is that there is no time to wait. The time to change is actually right now, and I think that the solution that we are now providing is touchable. It will have a big impact to our industry. It will be a big change for a lot of people. But on the other hand, we are now so close, so we should not wait anymore. We have an available solution. So I think it's. Like this child in our video was saying, the time is now. The time is now to change.
In fact, it should be pointed out, in fairness to Kalmar, that you started with the electric tractor, and that's obviously gained a lot of traction. The electric tractor is clearly taking off. We know there are orders and deliveries, multiple orders and deliveries in various parts of the world. So you started with the tractor, 2018-19, within 3 or 4 years, you're now offering a full range of electric mobile plant. So that is an achievement, and that is a key achievement, obviously. Anyway, I think that's it, because no one wants to ask any questions. So, well, we've had questions. Thank you very much. Thank you for your interest and participation, everyone, and thank you to the organisers, because the AV has been pretty good. So thanks very much. Thank you.
Thank you.